Math is made easy, no more fear. Target online class, we got you. Wherever you want it from, we got what you need. Target online class.
Good day, viewers all over the world. You are welcome to Target online class. Today we want to do revision. Revision on indices, logarithms, and surds. So we want to do revision on the three concepts: indices, logarithm, and surds. So I have videos on all these three concepts: indices, logarithm, and surd. But today we just want to do a kind of revision on these three concepts. So I'll be starting with indices. Indices. Of course, if you have, let's say you have x times x times x times x. So x in 4 places. How do you abbreviate this in order not to occupy space or to make it simpler? That would be s into 4 places. That is x times s is s squared. S times s is another s squared. So s squared plus s squared. That's going to give us x raised to the power 4. This simply means that we have been able to rewrite all this in this form. Then this s is called the base. We call this x base. And this 4, which is called, you either call it power, or you call it index, or you call it exponent. So you can actually use those 3 words interchangeably. Is that you call it power, index, or exponent. Index is plural, indices is plural. So under indices, there are laws that guide indices. The first law says that if you have s raised to the power a multiplied by s raised to the power b, the law says that it will be s raised to the power a plus b. That is, if the base are equal and the operating sign is multiplication, you go ahead and add the power. That's what the first law says. The second law says that if you have s raised to the power a divided by s raised to the power b, it will be s raised to the power a minus b. In this case now, the base must be equal before we talk about indices. Then if the operating sign is division, you go ahead and subtract the power. Then there's this other law that says that if you have s raised to the power 0 is 1, that is, anything raised to the power 0 is 1. So there's a law that says that. Then the fourth one is when we have s raised to the power minus a. That is, if the power attracts a negative sign, you can actually write it as s raised to the power 1 over s raised to the power a. So this is the positive form of writing the law. That's the positive form of writing this. I think these are the basic law. These are the basic laws that we have in indices. Of course, there are some other law that has to do with when we have square roots, when you have cube roots. We can actually do that without going through any law. So we are going to see examples, but these are the basic laws of indices. Once you know this, then you should be rest assured that you will be able to solve any problem under indices. So we are trying to do a kind of revision on indices, logarithm, and surds. So I started with indices. So let's see examples. Let me call it this example 1. I'll just say evaluate or simplify. Simplify the following. The first one, say A. Let me call it A, where you have 16 raised to power 1 all over 8. Then B, we have 2 raised to power a minus 1. C, you have 0.04 raised to power half. Then D, where we have 2 raised to power 0 plus 4 raised to power minus half, all squared. Then E, we have 5 raised to power x multiplied by 5, 25 raised to power x minus 1 all over 125 raised to power x plus 1. So let's attempt the questions that we have on the board. The first one, we have 16 raised to power 1 over 8. Of course, the base is 16, and the denominator of that power is 8. So this is what you look at. Is it possible to rewrite 16 as index of maybe 2? I think it's possible. So I'm going to change this 16 to 2 raised to the power 4. 2 in 4 places is 16. So I'll change this to 2 raised to the power 4. Then multiply by 1 over 8 is the power. 1 over 8. 4 here 1. 4 here is 2. So at the end of the day, I'm going to have 2 raised to the power. I'm going to have 2 raised to the power 1 over 2. And of course, if you have half, half simply means, if you have raised to the power half, simply means square root. And that will give us square root of 2. That's what we are going to get. The answer will be square root of 2. Then we go to the second one, where we have 2 raised to the power a raised to the power minus 1. Of course, this is 2. It's a constant. Then when we have, if I want to rewrite this a raised to the power minus 1 in positive form, it will multiply by dot connote multiplication. A raised to the power 1 is as 1 over a. And we are going to have 2 over a as the answer. So this will be the answer. Then we go to the third one, where we have 0.04 raised to the power half. Of course, this is decimal fraction. We can actually convert this to normal fraction. That is, we are going to have this. Let's shift this decimal point 1, 2. That will be 4 all over 100. Everything raised to the power half. That's what we are going to get. That's what we are going to get. That's what we are going to get. Then in this case, I can write 4. I will write 4 as 2 raised to the power 2. Then I will write 100 as 10 raised to the power 2. Everything raised to the power half. So the denominator is raised to the power 2. The denominator is raised to the power 2. I can combine these two to say 2 all over 10. Everything raised to the power 2 multiplied by half. Half is the exponent. Then 2 can actually cancel 2. At the end of the day, I'm going to have 2 all over 10 raised to the power 1. And that is 0.2. That will be the answer in this case. Okay? That will be the answer to the third question. Then we go to the fourth question. If we look at the fourth question, let me attempt it here. The fourth question, D. We have 2 raised to the power 0 times plus 4 raised to the power minus half, all squared. Of course, from the law, we know that 2 raised to the power 0, anything raised to the power 0 is 1. This will be 1. Plus, I can change 4 to 2 raised to the power 2. I will have 2 raised to the power 2 multiplied by minus half. This will cancel this. Everything squared. At the end of the day, I'm going to have 1 plus 2 raised to the power minus 1, all squared. So this will be the same thing as 1 plus 2 raised to the power minus 1, same thing as 1 all over 2, all squared. That's what we're going to have. Then if we find the LCM there, what do we get? If I find the LCM here, I'm going to get 2. That will be 2 plus 1, all squared. At the end of the day, I'm going to have 3 all over 2, all squared. This same thing as 3 squared all over 2 squared. And at the end of the day, I'm going to have 9 all over 4 as my answer. So 9 all over 4 will be the answer there. 9 all over 4 will be the answer. So, and you can, this is improper fraction. You can actually change it to mixed number to say 2 all over 1 all over 4 as the final answer. So under indices, you can actually check my videos on indices. I have videos on indices and simple exponential equations. Just go through my videos on indices and simple exponential equations to have better understanding about all these concepts. Look at, in this case now, we have 5 raised to the power x times, look at 25. I can change 25 to 5 squared. So I'm going to change this to 5 squared. Then the power is x minus 1. So I'll put it into bracket x minus 1. All over, I can change 125 to 5 raised to the power 3. 5 in 3 places is 125. So I'm going to have 5 raised to the power 3 into bracket x plus 1. No, x plus 1 was the initial exponent that we have. Since we decided to change 125 to raised to the power 3, so it is going to attract bracket. Bracket connotes multiplication. So we have 5 raised to the power x multiplied by 5 raised to the power 2x minus 2 all over 5 raised to the power 3x plus 3. I start to open up. Then from there, the base are equal. The operating side is multiplication. I will add the power. So I have 5 raised to the power x plus 2x minus 1 and minus 2 all over 5 raised to the power 3x plus 3. Then here, the base are equal and we have division line. So what I'm going to do is that I will subtract this power from the first one. This x plus 2x is 3x minus 2 minus into bracket the power of this, the denominator 3x plus 3. Then from there, we are going to have 5 into bracket 3x minus 2 minus 3x minus 3. Minus 3 we cancel 3x. Then we are left with 5 raised to the power minus 5. Because minus 2 minus 3 is minus 5. Then this same thing as saying 1 all over 5 raised to the power 5. And that will be the answer. So that will be the answer. So that is that. about indices. I'll just give two examples on simple exponential equation. Let me call that example 2, where we have simple exponential equation. So in that case, we are going to solve. It says solve the following. I'll give just two examples. So please, if you want to know more about indices, just check my videos. I have videos on indices. Check my videos on indices and simple exponential equations. Is the video is that you find it at live or videos? Just go to my YouTube channel. Solve the following: 2 into bracket 2 raised power x is equal to 8. Then let's take another one where we have 2 raised power x plus 1 plus 2x is equal to 24. So let's just solve this under simple exponential equations. Of course, this is what we are given, and this is what we are asked to solve. The first one, I'm going to start with the first one. I have 2 into bracket 2 raised to 2 into bracket x is equal to 8. Of course, it depends on the approach that you want to apply. I might decide to divide both sides by 2. It's allowed. This will cancel this. Then I'll have 2. That can actually be 2 raised power x to be equal to 2 here 1, 2 here 4 to be equal to 4. Then 2 raised power x can be equal to 2 raised power 2. Then this is the logic here. If the power are equal, you equate the base, and vice versa. And if the base are equal, you equate the power. Therefore, since this is 2, this is 2, you equate the power. Therefore, x is equal to 2. Okay? So let's go to the second one, b, where we have 2x plus 1 plus 2 raised power x equal to 24. So in this case now, I can split this with my knowledge of law of indices. I can say this is say as 2 raised power x multiplied by 2 raised power 2, 2 raised power 1, because multiplication connotes dots connotes multiplication. So if you have this, the base are equal, you add the power when it is multiplication, and if it's division, you subtract. So I can also reverse it. Then plus 2 raised power x is equal to 24. Of course, 2 raised power x is common. If I bring that out, I'm going to have 2 raised power 1, which is 2. 2 plus 1 is equal to 24. Then here I'm going to have 2 raised power x multiplied by 3 is equal to 24. I can divide both sides by 3. 3 will cancel 3. 3 here 1. 3 will reduce it to 8. So I have 2 raised to power 8. I have 2 raised to power x. I'm going to have 2 raised to power x. 2 raised to power x to be equal to 2 raised to power 3. 8 is 2 raised to power 3. The base are equal, you equate the power. S is equal to 3. So simple exponential equations. So if you really want to know more about this, you can just go to my YouTube channel. Go to my YouTube channel. I have videos on indices and simple exponential equations. So I'll move to the second topic now, which is logarithm. Logarithm. So what is logarithm? Of course, another logarithm the one we want to apply today is log to base 10 and natural logarithm. Of course, we know we have some that where we use table, where we make use of table. I know you are familiar with that. When we have logarithm of number less than 1 or logarithm of number greater than 1, we also have question on we have something of such. But today we want to look at logarithm of number where we have base 10 and natural logarithm. I've just talked about natural logarithm. So what is logarithm? The logarithm to base y. The logarithm to base y. The logarithm to base y of a number p is the index x to which y must be raised. To which y must be raised to be equal to p. That is, thus if p is equal to y raised by x, then x is going to be log p base y. That's what we are trying to say. That the logarithm, of course, if where we add log to both sides, this is what we're going to get. The logarithm to base y of a number p, this number p, is the index x to which y must be raised to be equal to p. That is, thus, if p is equal to yx, if we take log on both sides, we are going to have log y raised by x. Then x can actually come down. X can come down. X can actually come down. Then we have log y. So this is log p. Then this is log p. Then divide both sides by log y. Divide both sides by log y. We are going to have our x. X will actually be log p all over log y. Then log p all over log y is the same thing as this. When we actually want to find change of base, log p all over log y is the same thing as this. That is the concept under change of base. I've tried to introduce change of base here. That this is equal to this. So the logarithm of a number, say the logarithm to base y of a number p is the index x to which y must be raised. So that is that about logarithm. Then I've been able to introduce change of base here. That's when we have log p base y is same thing as log p divided by log y. So let's quickly look at laws of logarithm. We look at laws of logarithm. There are 5 laws of logarithm. So if you really want to know more about this logarithm, you can check my videos on logarithm. Laws of logarithm. Before we take example, the first law says that if you have log p base a plus log q base a, it will be log pq base a. That is, if you have log p and the operators and log q, the operator sign is addition. If it is addition, you can multiply. You want to combine the two. The second law is like the first, log p a minus log q a. It will be log p divided by q base a. That's the second law. Then the third law says that if you have log q raised to power p base a, or let's say raised to power b base a, the law says that this b, the power can come down to be b log q a. Then there's another law that says that log p base p is equal to 1. That is when you have the same, when you have the same log and base is equal to 1. Then the last one says that when you have log p 0 is equal to 0. So that's the last law. That is the last law. If you have log p base p is 1. But if you have if you have log 1, if you have log 1 base p is equal to 0. That is, once you have log 1, then the answer will be equal to 0. Now note, we should note that if you are not given the base, just say you are just given log, say log 3 or log 5 or log whatever you are given, you assume the base to be equal to 10. That has been the standard. In a logarithm, if you are not given the base, assume the base to be 10. That has been the standard. Okay, so these are laws of indices. Then there's what we call the natural logarithm, where we have log p base e. So e simply means this is a natural logarithm. At times, when we move at the advanced stage, you are going to see something like this. This simply means in p. So this is natural logarithm, where e has value on the scientific calculator. So please note that you can also have natural logarithm. So if you really want to know more about these laws of indices, then you can actually check my videos. I have videos on logarithm. Just go to my YouTube channel and check. We just want to do revision for tonight. It's just revision. So let's take example. Example 3. Let's take example. We can call that example 3. We can call example 3. We can say, let's take example. Say simplify the following. Simplify the following. A log x base s raised by 9. Then b, where we have log when we have log 8 base 2 plus log 4 base 2. Then C, let's take another question. C, we have log 4 base 2 plus log 2 base 4 plus log 5 base 25 minus. Then D. So D, we can take another question. Let's first solve these three. Then we go ahead and take another question where we are given some values. Okay, A, the first one. We have log x raised to power 9. So what will be the answer here? Of course, from the third law of logarithm. This power can come down to be 9 log x base x. Then if it's plus log, here I can write this and say log, I can change it to 2 raised to power 3 since I have 2 here. Then plus, I can change 4 to 2 raised to power 2. That will be 2. Then from here, I'm going to, this 3 can come down. I'll have 3 log 2 base 2 plus this 2 can come down to be 2 log 2 base 2. So in this case now, log 2 base 2 is 1. Log 2 base 2 is 1. So I'm going to have 3 multiplied by 1 plus 2 multiplied by 1. That will be 3 plus 2. And that's going to give me 5. Then if you look at this third one, now. Let me solve that here. Look at this third one. This third question now. What do we have here? I can change this to log 4, log 2 squared. I'll change 4 to log 2 squared plus log 2 base 2 raised to power 2, that is 4, minus log 5. I'll change 25 to 5 raised to power 2. Now, look at the implication. Without going through any stress. Of course, I know that log 2 base 2 is 2. This 2 can come down, right? So I'm going to have 2 here. Plus, in this case now, you have log 2 here, but at the denominator, you have you have 2 raised to power 2. The other time I talked about change of base. What I have here can actually be split to be log 2 divided by log 2 base 2. So this 2 can come down. We have 2 here, then there won't be 2 here again. This will take care of this, and then I'll have 1 over 2. So instead of going through all this test, if you have multiple choice question, you don't have time. Just look at it and get your answer. If this is multiple choice question, objective question, then you don't need to stress yourself. This is what you are supposed to do. Just say 2 plus. Here I'm going to do, I'll just write half. Then minus, in this case also, I'll have minus half because log 5 will be the same. It will be log 5 divided by log 5 raised to power 2. 2 can come down, half. So half. This is half from the expression here. This can cancel this. At the end of the day, the answer is 2. So please, we have to be very smart when we are dealing with multiple choice question. Question that require limited time. So we don't have the whole time. We are not going to have the whole time. So we must be very smart when we are dealing with that. So let's take one more example. On that. Then we go to Surds. We are just trying to do revision. Given that log 2 base 10 is equal to 0.3010, then log 3 base 10 is equal to 0.4771. We have to find what I'm about to write now. Find A log 6 base 10. That's the first thing that we want to find. Then B log half base 10. Then C, we can talk about log 7210. Okay, so these are just multiple choice questions that require short answer. We have to be very smart. In this case now, we have log 6 base 10. Of course, I can change this to log 2 times 3 base 10. So if this addition we multiply, if the reverse will be the case. Here I will not split it. I will say this is log 2 base 10 plus log 3 base 10 according to the first law of logarithm. So what do I have here? Log 2 is 0.3010. then plus this is 0.4771. So if I add these two together, I'll have 1, 8, 7, 7 point. So this is what I'm going to get. Okay. The second one, I have log half base 10. Of course, I can change this to log 10. This 2 raised to power minus 1 from log of indices is possible. Then this minus 1 can come down so that I'm going to have minus 1 log 2 base 10. That will be minus 1. What is log 2 base 10? Is 0.3010. So that I'm going to get minus 0.3010. And that's the answer. So we have to be very smart when we are dealing with multiple choice questions that require short answers. Then the third one, yeah, we have log 72 base 10. So this is log. Can we express this as index of 2? Is it possible? Yes, we can change this to 8 times 9. 8 times 9. 8 times 9 is 72. So that I will split this to log 8 plus log 9. Of course, we can rewrite this. We can actually rewrite this. So we continue from there. We can rewrite this to be log 2 raised power 3 10 plus log 3 raised power 2. 3 raised power 2 10. So this can actually come down. Then we have 3 log 2 10 plus 2 log 3 10. Okay, so that at the end of it, you have 3 into bracket 0.3010 plus 2 into bracket 0.4771. That's what we are going to get. Then from there, if we multiply, we have 0.9030 plus here is 2, 14. This 15, that will be 9. That's what we are going to get. So if we add the two together, we are going to have 2, 7, 5, 1.8. That's what we are going to get. If we do it correctly, maybe that's what we are going to arrive at. So that is that about logarithm. Then we have logmatic equations involving logarithm. But time will not permit us to do that. You can just go ahead and check my videos on logarithm and logmatic equations. So I have videos on that. So this is how to approach it. We are just doing revision on these three concepts: indices, logarithm, and surds. So I will now go ahead and introduce the last one, surds. Surds. So I'll go ahead and introduce surds. This is the last concept that we are going to discuss for today. So what is surd? Of course, we must have had this, or maybe some of us are here, we are hearing this for the very first time. Irrational numbers. I have videos on irrational numbers, a set of numbers. Just listen to my videos on set of numbers. Irrational numbers, which are roots of rational numbers, are called surds. That is, we have this concept surds as a result of irrational numbers. An example of surd is root 2, square root of 3, square root of 5, etc. So that is the beginning of surd. So we should note that if you are given any question on that surd, it is expected that we break the question into two and make sure that one of the value that we have is a perfect square. What do I mean by perfect square? A perfect square is a number that has both a square and a square root to be equal to a whole number. So this is example of surd. This is just an example of surd. Then before we take examples, I would love to talk about laws. We have laws of surd, or you call it rules. You know, you call it laws or rules. It depends. Maybe let's call it rules of surd. The first one says that if we have square root of a times b, the same thing as square root of a times square root of b. That is, if you have it together, the square root of two values, we can actually go ahead and split it. We are permitted to do that. The second law says that if you have square root of a all over b, that is, we have square root of a fraction, we can split it as square root of a all over square root of b. So we are permitted to do all this. But if you have square root of a plus or minus b, it is not the same thing as square root of a plus or minus square root of b. That is, for multiplication and division, we are permitted to do that. But once it comes to addition and subtraction, then we are not permitted to to split it. That's what we are trying to say. So I'll just give 1 or 2 examples on this. I'll give 1 or 2 examples on this before we go to addition and subtraction of Surdic equation. So, for instance, if you have square root of 18, the question says simplify square root of 18. How do we simplify this? This is what we are expected to do. We will think about 2 factors of 18, in which one of the factors must be a perfect square. That is, there are so many things that you multiply to get 18. That is 6 times 3, 18. Both 6 and 3, they are not perfect square. We can also say 18 times 1 is 18. But what if you say 9 times 2? 9 times 2 is 18. 9 is a perfect square. Why is 9 a perfect square? The square root of 9 is 3, and the square of 9 is 81. That makes 9 a perfect square. When you talk about a perfect square, it's a number that has both the square and the square root to be equal to our own number. So in this case now, I can go ahead and split this. So the square root of 9 times square root of 2. The square root of 9 is 3 multiplied by root 2, and that's what we have. Root 18 is the same thing as 3 root 2. This is the basic form. This is the basic form of this surds. So it is essential and important for us to reduce surds to its basic form, for us to be able to perform operations on surdic number. Root 18, we have been able to express this as 3 root 2. It is compulsory to reduce surds to basic form for us to be able to perform basic operation like addition, subtraction, multiplication, division on surds. So let's take note that it is compulsory to reduce surd to its basic form for us to be able to add or perform operations, either addition or subtraction on it. Then, let me quickly talk about similar surds. Similar surds is when they have the same thing in common. For instance, when you have 2 root 3 plus 2 root 3 plus, let's say, root 75. Can we add these two together? Is it possible? Similar surds simply means they have something in common. 2 root 3, 3 root 3, 7 root 3. That is, something is common. Root 3 is common. So they are similar. But you can't say 2 root 3 and 3 root 2. They don't have anything in common. So you cannot perform any operation on this. Okay? You just leave it like that. So now let's look at addition. Addition of surds. In this case, now if you have 2 root 3 plus root 75, what will happen? 2 root 3 plus, I can break this down to 25 times 3. Then at the end of it, I have 2 root 3 plus square root of 25 times square root of 3. And at the end of it, I have 2 root 3 plus what square root of 25? That is 5 root 3. Then these are similar. They are similar because they are root 3 is common. I can go ahead and add these two. I'm going to have 7 root 3 as my answer. So that's that about similar surd. So since we know similar surd now, then I can introduce addition and subtraction of surds. Addition and subtraction. I only give 2 examples. Addition and subtraction. Subtraction of surds. So simplify. Simplify the following. Let's say simplify. A 2 root 12 plus 3 root 48. Then B, I have 4 root 200 minus root 8. Okay? So now let's look at this. What do we have here? The first one. I have 2 square root of 12 plus 3 square root of 48. Of course, these are not similar. I cannot do anything. But let's look at what we have inside the square root and break it down. I can change this to 4 times 3. 4 times 3 is 12 plus this is 3, 48. I can actually break 48 down into 2 factors, in which one will be perfect square and the other one will be perfect square. I can say this is 16 times 3. So that from here, I know that square root of 4 is 2. So instead of 12 now, I'll change this to 2 root 3 because square root of 4 is 2. This will now be 2 root 3. So I'm going to have 2 multiplied by 2 root 3 here. Plus, here I have 3. Then I can find the square root of 16 to be equal to 4. That will be 4 root 3. So this will be 3 times 4 root 3. No, we have this 3 there before. Then here I'm going to have 4 root 3 plus 3 times 3, that's 12 root 3. These are similar sorts, root 3 root 3. So I'll add 12 plus 4. That's 16 root 3. That's what we're going to get. Okay. Then we'll move to the second one, where we have 400 root 200 minus root 8. Of course, I can break this down to 100 times 2, because square root of 100 is 10. Minus, I'll break this to 4 times 2. Then here, I'm going to have 4 multiplied by 1 square root of 100 is 10. That will be 10 root 2. Minus square root of 4 is 2, 2 root 2. At the end of the day, I'm going to have 40 root 2 minus 2 root 2. And that will be 38 root 2. So that's how to add or subtract. So as I've said earlier on, it is important to reduce sort to its basic form for us to be able to add and subtract such sorts. So let's look at multiplication. Multiplication of sorts. I'm going to take just one example, 2 examples under that. Multiplication of sorts. So what do we do under multiplication of sorts? We just simplify square root of 5 minus 2 multiplied by square root of 3 plus square root of 6. Then the second one, we have 1 minus root 2 multiplied by 1 plus root 2. So let's quickly do this. Let's quickly attempt to this. So under multiplication of sorts, also, what will happen? Then this is what we do. We just multiply the 2. So we are going to expand, do the normal expansion. Root 3 times 5, that's root 15, plus 5 times 6, that's root 30, minus 2 times root 3, that will be 2 root 3, then minus 2 root 6. So can we break this down? Can we split this? 3 root 5. We can't break it down. It will be root 15. 30. We don't have any factor that can be perfect square, so we leave it like that. So the final answer will just be root 15 plus root 30 minus 2 root 3 minus 2 root 6. That will be the final answer. Because we cannot do anything. We can't break all this down to the basic form. So that's what we do. Then look at the second one. Here we have root 2. Then 1 plus root 2. Of course, we did the normal expansion. That will be 1 plus root 2 minus root 2 minus root 4. This will take care of this. At the end of it, we have 1 minus square root of 4 is 2. That's 1 minus 2. That's the answer is minus 1. That's what we have there. Okay, so that's what we have. We now quickly talk on conjugate. Conjugate sorts. We quickly talk on conjugate sorts. Under conjugate sorts, is very simple. Why do we need conjugate sort? The knowledge of conjugate sort is actually required for us to be able to rationalize. That is, if you have sort that involves fraction, we talk about rationalization. So the knowledge of this conjugate sort is actually important for us to be able to rationalize. Example, e.g., if you have a sort 1 minus root 2, like the example that we have, its conjugate will just be 1 plus root 2. That's just it. Conjugate simply means if it is negative, change it to positive. And if it is positive, you change it to negative. That's the meaning of conjugate. Not only that, we should note that if we use a sort to multiply its conjugate, we are going to get a rational number, a whole number. Please first note that when you use a sort to multiply its conjugate, we are going to get a whole number. In this case now, like the second example that I gave the other time, that's 1 plus root 2 minus root 2 minus root 4. This will cancel this. And then we are going to have 1 minus 2, which is minus 1. So when you use a sort to multiply its conjugate, be rest assured that you are going to get a whole number. You are going to get a whole number. That is that about that. The knowledge of conjugate sort is actually required for us to be able to do what is called rationalization of sort. So rationalization of sort is when we have sort that involves fraction. And that will be the last concept that we're going to revise on today. Rationalization. That's the last thing that we're going to talk about. Rationalization of sorts. Rationalization of sorts. For instance, if you have 1, say you have 1 over root 2. Of course, in mathematics, we are not comfortable having square root at the denominator. Then what we normally do is that we say 1 over root 2. We now multiply both the numerator and the denominator by root 2. At the end of the day, I'm going to have root 2. Root 2 times root 2 is root 4. What is root 4? Is 2. So I have square root of 2 over 2. So we are comfortable with this compared to this. Okay? And that's simple meaning of rationalization. That is, if you want to rationalize the surd, just look at the denominator. If it's root 5, just multiply both. What you do to the top, what you do to up, you do to down. So that's what you are going to have there. So this one is very simple and straightforward. But what if the denominator has addition or subtraction involved? Then let's say example, simplify. I'm going to take just 2 examples on this, because if you want further information on Surds, you can actually go to my YouTube channel. I have questions on Surds. I have video on Surds. 3 plus root 2 all over square root of 5 plus square root of 3. Then the second one, if you have 1 plus root 5 all over 1 minus root 5. So what do we do here? So we're going to do this and call it a day. In this case now, we have to simplify this. The first one, 3 plus root 2 all over root 5 plus root 3. So if you want to simplify this, we are going to multiply both the numerator and the denominator by the conjugate of this surd. And that's what's called rationalization, by the conjugate of this surd. That's why the knowledge of conjugate surd is actually important. That is, I will have root 5 minus root 3 all over root 5 minus root 3. So this we multiply this. We have 3 plus root 2 multiplying root 5 minus root 3 all over root 5 plus root 3 multiplying root 5 minus root 3. So if you look at the numerator, I'm going to have 3 root 5 minus 3 root 3 plus root 10 minus root 6 all over. If you look at the denominator, I'm going to have 25 square root of 25 minus square root of 15 plus square root of 15 minus square root of 9. This will cancel this. So when you use a surd to multiply its conjugate, just square the first one and the second one. That gives you the answer. So you don't need to bother yourself. Here I'm going to have 3 root 5 minus 3 root 3 plus root 10 minus root 6 all over. This is 25. Square root of 25 is 5 minus square root of 3, that will be 1 over 2. And that's the answer. We cannot simplify further from there, because all this denominator, they have nothing in common. So they don't have similar sorts. So there's nothing we can do. We will stop at that, and that's the answer. So we go to the second one. The 1 minus square root of 5, this big part of the question. What do we do here also? We are going to rationalize. Rationalize in the sense that we multiply both the numerator and the denominator by the conjugate of the denominator. Here we are going to have 1 plus root 5. The conjugate of this is addition. It was minus before, then the conjugate. Then if we express that, if you multiply that, we have 1 plus root 5, multiplied by 1 plus root 5, all over 1 minus root 5, multiplied by 1 plus root 5. The conjugate is minus. So from there, what do we get? We are going to have 1 plus root 5 plus root 5 plus, that's plus 5. All over, here I'm going to have 1 minus, because if I open up, I'm going to see the middle is the cancel out. Just square the first one minus the square of the second one minus 5. So that at the end of the day, I'm going to have 1 plus, this will be 6 plus 2 root 5. All over 1 minus 5 is minus 1. Then 2 is common. We can actually bring out 2. From what we have there, 2 is common. We can bring out 2. 2 is common. So that from there, we are going to say that we have 2 into bracket 3 plus root 5 all over minus 4. Here 1, here 2. So the final answer will be minus 3 plus root 5 all over 2. That will be the final answer. So I'd love to stop here because of our time. As I've said earlier on, I have videos on indices, Logarithm and Surds on my YouTube channel, Tutorial Online. So you can subscribe to my YouTube channel and check out those videos. This is just a revision, kind of we try to revise what we have done before. Thank you, and God bless you all.